Alright, time for the solutions for the odds on the Master Quiz 6, which is all about sequences. On number 1, I'm noticing a pattern of shifting between positive and negative. The only way you're going to do that is if you have a geometric sequence instead of a arithmetic one, because you have to times by a negative to switch between positive and negative. So we're going to have a common ratio, and in this case it's going to be -3, because you times by -3, times by -3, times by -3, all the way down. And actually, let's do that to get a few of these other ones. Alright, if you times by -3, that maintains, you're going to get these terms, -162, positive 486, and -1458. So there we go. You need to have your common ratio and your initial value to write both your functions. Initial value is -2, and your common ratio is -3. So now we have that. On the recursive one, every number is -3 times the previous one. And you need to start at -2. So that's what that recursive one looks like. That's what it's telling you. But, you know, with fancy math symbols. For the explicit function, you need to say, if you want the nth term of the sequence, you have to take -2, and you have to times it by -3 to the n-1 power. So there we go, that one's good to go. And next one, we need to get a sub 10. If you want to get a sub 10, you have to plug it into the explicit function, at least if you want to do it in a timely manner. You could plug it into the recursive one, but then you have to get the 9th one, and to get the 9th one, you have to get the previous one, and so on and so forth. Anyway, when you do that, you're going to get positive 39366, or 39,366. And let's jump down to number 3. I'm already just looking at this, noticing a pattern of adding 3 every time, which will give you 16, 19, 22. And since you're adding every time, you have a common difference, which is that number you're adding every time, which makes this one arithmetic. And if you want the recursive formula, you have to know your common difference. 3, you have to know your initial value, 4. And so every number is the previous one, plus 3. And the first term of your sequence is 4. So there's a recursive function. The explicit one, if you're not quite sure how to write things down or what things are coming from, look at your notes. It's on there, these forms here. If you want any term in this sequence, you have to subtract 1 from that term, times it by 3, add 4, and you'll have your term of your sequence. For instance, let's say you want to get a sub 20. You take 20 and plug it into your function for n. 20 times 3 is 60. And when you subtract that, you get 61. So it's going to be 61. So there you go. There's 1 and 3. Moving on to 5. Again, I have noticed this pattern of switching between positive and negative. So this one is going to be geometric. And it's going to have a common ratio since it's geometric. And I'm noticing here it's dividing by 3 every time, so my common ratio is going to be -1/3. Because you have to times it by -1/3 is the same thing as dividing by -3. If you want to get the next terms of the sequence, just take what you currently have and times by -1/3, which is going to give you -4/9, and then positive 4/27, and then -4/81. The recursive formula requires your common ratio and your initial value. So every term is equal to -1/3 times the previous one, and your initial value is -36. So there's that. The explicit formula, every number is equal to -36 times -1/3 to the n-1 power. Remember, multiplying multiple times gives you an exponent. That's how you know which of the explicit formulas to is the one with the exponent. And now we get a sub 7. Well, we already got it. Right here. This is the first, second, third, fourth, fifth, sixth, 7th. Yeah, we already got it. And so I'm not going to plug that into any of my function stuff. I'm just going to write it down. -4/81. We already got it. Sweet. Moving on to the next one, number 7. So this one starts at 8,000, going down to 2,500, so on and so forth, going down. It's looking like it's dividing by a specific number each time, which means we're going to have a common ratio. And that common ratio is going to be 1 over that number we need to be dividing by, which I believe the number is 4. Yes, indeed, it is 4. So our sequence type is a geometric sequence. We'll jump over to the functions after we get these 3 terms here. We need to take this and divide by 4. Well, it doesn't go evenly. It doesn't even reduce. So we're going to get 125 divided by 4. And we're going to get 125 divided by 16. And then we're going to get 125 divided by 64. Because that's what you're going to get when you times the previous one by 1/4. So we got that. Our start number is 8,000. And our common ratio is 1/4, so every term in the sequence is 1/4 the previous one. And your first term of your sequence is 8,000. So start at 8,000, to get the next number you have to times by 1/4. And for the explicit formula, you have to take 8,000 and times by 1/4 to the n minus 1 power. And so that's your whole explicit formula. If you want to get a sub 8, you can take that and plug it into your explicit formula. 8,000 times 1/4 to the 8 minus 1 power. And when you compute that, you're going to get, it's going to give you 125 over 256. And that's going to bring us to number 9, which actually has a kind of an interesting pattern here. It's looking like we're losing a little bit. It's not, hold on one second, let me look at that. Well, as I investigated further into this little sequence, it doesn't have a common ratio. It doesn't have a common difference. It doesn't have a common pattern, really, that much at all. And so, we're not going to get a function for it, and we're not going to get a type. It's not geometric, because you're not multiplying by the same number every time. It's not arithmetic, because you're not subtracting by the same number every time. So, yeah, we're just going to have to skip that one for now. Jumping over to 11, Romo did 12 hours of first, well, $12 first hour, $15 second hour, 20 seconds third hour, and so on and so forth. How much we get for the 50th hour? Well, to get a sub 50, you should get an explicit function for this sequence. Our initial value is $12, and it's looking like it's an extra $5 each time, so your common difference is 5. This one's arithmetic. Add 12 on the end. If you want the 5th hour of work, you're going to plug in 50. Which is going to give you, hold on one moment, it's going to give you $257, which is, not too bad, especially if you got it in like 1 hour, so that'd be awesome. Number 13, hot tubs increasing in temperature. Sequence represented by arithmetic or geometric. Well, you're not adding the same amount each time, so arithmetic is out, which is going to leave us with geometric. And you have to determine the common difference or common ratio. Well, if you want your common ratio, you just take any term in the sequence and divide by the previous one. And when you do that, you're going to get 1.1, which is your common ratio. So we'll write that common ratio. You can write the explicit term for the nth term. Well, it depends, would be hour 7. Well, the nth term in the sequence, that's just your typical a sub n equals, and you're going to write down your starting value, which is 70 degrees, and you're going to times by 1.1 to the n minus 1 power. So that's the explicit function, because this one's geometric, so it follows the geometric form. If you want to know what it's going to be after 7 hours, you're going to have to plug in 8. So 70 times 1.1 to the 8 minus 1 power. And when you compute that, you are going to get, it's going to give you 136.4 for 1 degrees, which will hurt a lot if you were to jump into that. And that's going to bring us over to 15. Inherited, land purchased for 30,000. So this is our initial value. The land increased by approximately 5% per year, which is actually quite good. Especially on the 30,000. Right, function represent this scenario. Well, the function angle, right, is going to represent how much money is in the bank. The approximate interest here, well, you're going to add that to 1 to get what you have to multiply by to get the next term of the sequence. So I'm going to write the explicit one. Your initial value is 30,300. And then you're timesing by 1.05. And it's being raised to the n minus 1 power. Because when you're doing the percent growth, percent decay, it's a geometric sequence. You have to times by the percentage number. Okay, approximate value of the land at year 2014. Well, if you have no idea how far that is, you can take 2014 and subtract out 1960. And that would be how many years it was, which was 54. Okay, so we know how many years it was, or which term in the sequence we're dealing with. Nope, that's number of years, which will make our term of sequence 1 more. And if you compute that, you'll probably be surprised at how ridiculously big this number is. So hold on, let me take a second. Well, it's going to come out to be nearly 5,418,160.88 cents. Alright, so that's how that one worked out. On number 7, down here we got this beautiful graph. You're going to have to just make your best guess at what the numbers are. I'm guessing it's 32, 16, 8, 4, 2, 1. So this is the geometric sequence of cutting it in half. So the type would be geometric. Common ratio is what you times by every time. So timesing by a half. Your initial value is 32. And so for the recursive formula, we're going to still write our same form. A sub n equals 1/2 of the previous term. Every term is the previous one. At least 1/2 of the previous one. And you're going to start your sequence at 32. For the explicit formula, you're going to have 32 in front, and you have to times by 1/2 to the n minus 1 power. And if you're going a sub 5, well, you can just get the 5th term of the sequence. 1, 2, 3, 4, 5. It's 2. 2. Alright, well, that one's quick enough. Moving on to 19, the last one for this little bit here. So what I'm going to do is take this and change it and write down some of the terms in my sequence for each mile. Let me get that real quick. Yeah, on this particular one, what you decide to have your sequence be is kind of going to change what your answers are. But we're going to assume this is the y values or your sequence values. So it starts at 15, just down 1 for every 25 miles driven. So this one actually just an arithmetic sequence with a common difference of -1. The recursive formula is going to be every term is the previous one minus 1. And the initial value is going to be 15. For the explicit formula, it's always going to start the same. -1 is going to go in front of n minus 1. And then you're going to add 15. And if you want the 5th term of the sequence, well, I can just keep going. It's 11. Okay, anyway, so there we go, and that's 19, done.